everyone, and welcome to our lesson on complex solutions of a quadratic equation. When we talk about complex solutions, we're referring to those solutions that have two parts, a real portion and an imaginary portion. Something we can use to find these solutions, one of our main tools is called the quadratic formula, and you can see that formula here. What we're going to do is we're going to take our quadratic in this form here, ax squared plus bx plus c, and we're going to call the a and the b and the c, we're going to put the a and the b and the c in this formula. The a and the b and the c are the coefficients on these terms here. So if you see a number in front of x squared, that'll be your a number in front of the x, and then a plain number at the end, that'll be your c. Sometimes we'll have to rearrange our equation to get it to this form before we can insert these values. Alright, something neat about this formula is that there's a portion of this formula called the discriminant. Let's go back and take a look. The discriminant is the portion underneath the radical here, the b squared minus 4ac, and the reason why it is special is because it is under a radical sign. We know that when we arrive at negative values under a radical sign, we are no longer dealing with real numbers, we're dealing with imaginary numbers, and I will come out of that. So that portion can tell us a lot about what kind of solutions we will arrive at. If we have a number that's less than 0 in that portion of the formula, we will have two real solutions, greater than 0. Two real solutions. That's because if a number is greater than 0 under the radical sign, we're okay, we're going to end up with a real number. If we have a number that's less than 0 under that portion of the formula, we will have no real solutions. Both of them will have an I attached because of that negative under the radical, so that means no real numbers. And if we come up with a special case where that portion is equal to 0, that's going to mean that our quadratic just has one real solution. It's actually going to be the same number twice, and we call that a double root. But since it's the same number, we think of it as one solution. Alright, so let's take a look at an example. We have a quadratic here, x squared minus 4x plus 7, and this one is already ready to go. It's in that standard form. So take a look at our coefficients here in front of x and then our plain number at the end. We don't have one in front of x squared, but we know that that means there's an implied 1 there. So our a here is 1, and our b is negative 4, and our c is going to be 7 that we're going to use in whichever formula we need to use. First of all, let's see how many solutions this has. We can find that out, remember, by looking at the discriminant portion. The part under the radical of the quadratic formula, b squared minus 4ac, is listed here, so let's take a look and see what's going to happen. Our b needs to go in the front for the b squared, and then our a is over here. I'm going to fill that in, and then our c was 7. Negative 4 squared is 16 minus 4 times 1 times 7, the product of 28. And I can see right now that we're going to have a negative number here. A smaller number minus a larger number is going to give us a negative number. In fact, it's going to be negative 12. We'll need that later. So what does this tell me? Remember, this tells me that this is the portion under the radical. Since I have a negative number, I'm going to have complex solutions, imaginary solutions. Okay. So what are those solutions going to be? Let's go ahead and find them. Alright, so recall our formula for finding the solutions, the quadratic formula, negative b plus or minus the square root, b squared minus 4ac, all over 2a. Alright, so remember our a, b, and c. Let's go copy those in. 1, negative 4, and 7. Okay, and we're going to fill them in. So I need negative b, that is negative 4. I like to put a parentheses here so I can make sure I include all the signs that I need to. Plus or minus Now we can fill all this in with our letters, but remember we already found this portion in the previous slide, so I'm going to go ahead and put that in there. We've already done the work for that. If you put in our b squared minus 4ac, you would have negative 12 as seen before. And then on the bottom I'm going to need 2 times a. Okay, so we just need to simplify now. So the opposite of negative 4 is going to give me positive 4, plus or minus. I've got the square root of 12i. I'm going to pull that negative sign out, and that creates an I, an imaginary number. So square root of 12i. All right, I'm going to do a little bit of side work here, because the square root of 12 can actually be simplified even further. If we break that down into a factor tree, I'm going to have 2 root 3. So that simplifies to 2 root 3. I'll keep my I, and 2 times 1 on the bottom is 2. Now we always want to go until we can't simplify any further, and I see some more things that we can do here. We can take our 2 on the denominator and use it to reduce both numbers up top. So I've got 4 over 2 here, which is going to give me 2. Forget the plus or minus. And then my coefficient of 2 over 2 on the right hand side simplifies to 1, so everything goes away except for my root 3 and my I. So my 2 complex solutions here are 2 plus root 3i and 2 minus root 3i. That plus or minus sign in the formula is where we're going to get our 2 solutions. Alright, we've got another example, and for this one we're just going to decide what kind of solutions we would have if we continued to solve them all the way out using the quadratic formula. So let's find our a, b, and c. Alright, again it looks like our a is going to be 1, that's the implied number in front of x squared. Our b is a positive 6, and our c is a 9. So let's see what kind of solutions this quadratic would have. Using the discriminant, we have our b in the front, our a next, and then our c. 6 squared gives me 36, minus 4 times 1 times 9 actually also gives me 36, which means I have 0. This is just the discriminant portion, remember, so what did that tell us? Well, if you recall, that means that this quadratic only has one distinct real solution. It's going to, if we were to put all of our a, b, and c into the quadratic formula, we would be adding and subtracting 0, which is not going to change the value that we have, which means I'll have the same answer twice. That's called a double root. So the 0 tells me one distinct solution. And here's something really neat, because this is what's happening on the graph when we're dealing with these complex solutions. Sometimes we will have a quadratic that does not cross the x-axis at all. It's located somewhere else on the grid where it's just not going through. That means there are no real locations that are solutions. So in that case, those solutions are imaginary. That's what's happening. This is a picture of what could be happening with our value of 0, when there's just one solution where the vertex is actually located on the x-axis. And then over here is an example where we would come up with 2 actual real value solutions. This is what's happening on the graph. It is crossing the x-axis twice. So that shows you the visual of what's happening when we find our solutions. And this concludes our lesson on complex solutions of a quadratic equation.